All right, welcome to our deep dive. Today we're taking a look at something pretty cool, the Kernelized Correlation Filter.
KCF.
Yeah, KCF, exactly.
Yeah.
We've got some really interesting research on this,
Mm-hmm.
and it's all about computer vision. So like, self-driving cars,
Right.
how they need to like instantly see pedestrians and stuff,
Yeah.
or security cameras that can track people. That's what visual object tracking is.
Absolutely.
And this KCF, it's a total game changer because it's crazy fast.
Yeah, it really is.
You can do all this in real time. I actually saw KCF in action recently at a robotics demo.
Oh, cool.
It was mind-blowing. Like, it tracked this robot arm so smoothly. It was amazing.
It's really impressive, tracking objects in real time. It used to be super hard because it took so much processing power.
Right.
But KCF, it kind of changed everything. It brought in all these cool techniques to really speed things up. And now real-time tracking, it's possible for all sorts of things.
So how does it actually work? Like, what's going on under the hood?
Yeah, so at its heart, KCF uses these things called correlation filters.
Okay, correlation filters.
Yeah, so imagine like you have a flashlight
Mm-hmm.
and it's shaped exactly like the object you want to track, right?
All right.
So you shine this flashlight onto each frame of a video,
Mm-hmm.
and the brighter the spot where the flashlight hits,
Right.
the better the match.
I get it.
That's basically what a correlation filter does. You train it to recognize a specific object,
Okay.
and it gives off this strong signal when it finds a match.
So it's like looking for that exact pattern.
Yeah, exactly. Like a detective picking out a face in a crowd, but for computers.
Oh, cool.
Yeah.
So where does the kernelized part come in?
Oh, that's the really cool
It makes it even more powerful, right?
It does. The kernel trick, it's like a magic trick, almost.
Oh.
It lets the algorithm work in a higher dimensional space.
Right.
Where it can see all these tiny details,
Mm-hmm.
but without actually doing crazy calculations in that space. It's like giving the algorithm a super-powered magnifying glass.
So it can see things we might miss.
Exactly.
Okay, that makes sense. But isn't working in higher dimensions like super resource intensive?
That's a great point. You'd think so, right?
Yeah.
But the kernel trick's really clever. It uses these shortcuts to get the same results
Right.
without all that heavy lifting.
Heard.
And that brings us to another cool part. Circulant matrices.
Circulant matrices. Okay, now you're just making stuff up.
Aha! I promise it's a real thing.
Right. But I don't need a math degree to understand this.
No, not at all.
Okay, good.
KCF takes advantage of how special these circulant matrices are.
Okay.
They have this unique structure that lets you do calculations super fast,
Uh-huh.
especially when you combine it with the fast Fourier transform,
Right.
like taking the express lane for processing.
So it's all about speed.
Absolutely. And that's essential for real-time stuff. Like, imagine self-driving cars.
Yeah.
They need to react to things instantly.
Right.
Like, if someone walks out into the road, they
Mhm.
need to brake in milliseconds.
Wow.
That kind of speed makes them way safer.
So we've got this super efficient algorithm.
Yeah.
It's lightning fast.
Mm-hmm.
But how does it actually work step by step?
Okay, good question.
How do you train it and then track things?
All right, so imagine we want to track, say, a red ball moving across the screen.
Okay, a red ball.
First, we got to train KCF. So we show it the ball in the very first frame. It
Mhm.
looks at all its features, the color, the shape,
Right.
and then it creates a correlation filter.
Mm.
It's like a unique fingerprint for that ball.
So then in the tracking phase.
Yeah, it uses that fingerprint to search for the ball in each frame.
Oh,
And as the ball moves, the filter keeps getting updated.
okay.
So it always knows where the ball is.
What if something gets in the way, though? Like if the ball goes behind something,
Ah, that's occlusion. And yeah, that's a tricky one.
so it can't see through things.
Not exactly. It can use what it knows to predict where the ball will reappear.
Oh, so it kind of guesses.
And in a way, yeah. It's not perfect, though.
Right.
Like if the ball suddenly changed shape.
Like if it deflated or something.
Exactly. Then KCF might lose track of it.
Okay, so it has limitations.
It does, yeah. Occlusion's a big one. And if the object's shape or size changes too much,
Mm-hmm.
it can struggle. But researchers are always working on ways to improve KCF,
Right.
trying to make it handle these challenges better.
So where can we see KCF in action today? Like what's it being used for?
That's the best part. It's super accessible. It's in all these popular computer vision libraries,
Okay.
like OpenCV, which is like the go-to for this stuff.
So anyone can use it.
Pretty much, yeah.
Yeah.
Developers can easily put it into their projects,
Oh, so-
and that means it's being used everywhere. Robotics, augmented reality,
Uh-huh.
even analyzing sports videos.
Wow, that's amazing.
Huh.
So what does all this mean for the future?
It's really exciting. I mean, think about it. If computers can already track things this well in real time,
Hmm.
where could this lead?
Exactly. What's next?
Well, KCF is a great tool, but it's just the beginning.
Yeah.
Researchers are working on even more advanced algorithms,
Yeah.
pushing the limits of what's possible.
That's incredible. What kind of things?
You could see breakthroughs in areas we haven't even thought of yet.
Like, give me some examples.
Think, like, self-driving systems that are even smarter than they are now.
Okay.
Or, like, medical imaging that can do things we can't even imagine yet.
It's mind-blowing to think about all the possibilities.
It really is.
We have these powerful algorithms, and who knows what impact they'll have on our world.
Yeah.
Like, what other amazing algorithms are out there just waiting to be discovered? And how will they change things?
It really makes you think.
It really does. It's something to ponder for sure.
Definitely.
All right, well, on that note, I think we'll wrap things up here.
Great talking with you.
Same here. Until next time.
See ya.